What is up, YouTube? Welcome back to another Moralis tutorial video. In this video, we're going to show you how you can send Chainlink tokens on the Polygon Mumbai testnet by writing to the Chainlink smart contract on this network. So if we open up the Polygon Mumbai Test Explorer, we see over here when we're in the contract tab, we have read functions for the smart contract, which you can automatically just read as you don't have to change the state of the smart contract and in essence, the blockchain. But we have also these write contract functions where you have to connect to Web3 because it'll require a little bit of gas to be able to change the state of the blockchain by, for example, transferring some tokens to a specific address for a specific value. And that is exactly what our app today does. We connect our wallet, so we're connecting to Web3, the blockchain. Let's go ahead and select account 1 over here, select connect, and automatically using Moralis, we can get the Chainlink token balance, which is 0.4 link. If we check out MetaMask, it gives us the same balance over here, link tokens 0.4. And then let's go ahead and select an amount we want to send. Let's send 0.1 Matic, so this is 17 zeros for the 18 decimal points that Chainlink token has. Enter a recipient. Let's go ahead and select our account 2. Opening up MetaMask, let's go to account 2 over here. Let's not connect it, but let's select it over here. Go back to account 1. Enter the recipient over here. And now we're able to send these tokens by interacting with the smart contract. Let's send these tokens. And we're able to send 0.1 link to account 2 on this Chainlink smart contract on the Polygon Mumbai Test Explorer. Let's go ahead and change the gas fee to high. So this contract smart interaction goes through for sure. Let's save this, scroll all the way to the bottom and press confirm. And now our contract should be going through like so. Our link has been sent, 0.1 link. So now we should only have 0.3 link. And if we jump over to account 2, connect this account, you see that this account now has 0.4 link, as we see on MetaMask as well, 0.4 link. And if we swap back, disconnect account 2, this should connect us back to account 1, which has now a new balance of 0.3 link. So interacting with smart contracts is super easy using Moralis and a Web3 library called Wagmi. Stay stuck in and I'll show you how to build this.
Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
All right, getting started here in our IDE, I have Visual Studio Code open with a starter repository called write contract starter. We have a backend folder and a front-end folder, and we'll start off in the front-end folder over here, which is a simple React project. Over here in the source folder, we have a app.js and a index.js like so. So what we'll do is we'll cd into this directory, cd front-end, and then install all the dependencies, npm I. This will just install some Web3 libraries and other dependencies we have for this project. Now in this index.js file, as these are installing, let's go ahead and import all the required functionality from our Web3 library Wagmi that we're going to use. So Wagmi is a very powerful library for React, and these are the things we will need from this library. Now what we'll do to start is configure all the chains our app will use. So in our case, we'll configure it for Ethereum mainnet and the Polygon Mumbai testnet, as we'll be making our write contract function calls for the Polygon Mumbai testnet. And we're going to use a public provider. If you'd like to get more stability, you could use your own Infura or Alchemy provider, but the public provider for this sample should do just fine. Then we're going to have to create a Wagmi client, and we do it just like that. Let's create a variable called client, and we'll use the create client function using our provider and WebSocket provider we destructed over here when we configured our chains at the start. And the final thing is to wrap your whole app inside a Wagmi config tag like so, using our client we created over here, and make sure to also close this tag up like so. So now we have Web3 functionality for our React app, and we can actually go ahead and see what it looks like. Our app.js should only have a Moralis logo, a title, send chain link, and a button called connect your wallet. So no functionality yet, but we can open this up, run npm run start, and this should open up your front end file. Rightio, so your front end should look like this. We have that nice Moralis logo, send chainlink as the title, and connect your wallet button. Of course, it doesn't do anything right now, but as our browser has MetaMask installed, let's now use Wagmi to be able to connect our wallet to this front end app, so we can then use our wallet that's connected to this front end, make a call to a write function on a smart contract on the Polygon Mumbai testnet. So jumping back into Visual Studio Code, we can close down our terminal, and over here in our app.js, let's import use connect and use account from Wagmi. So this will allow us to get the current account that's connected, and the use connect hook will allow us to connect to the web page. Then we'll use the MetaMask connector. Wagmi has a lot of different connectors if you want to use Wallet Connect, etc. We'll just use MetaMask for this case. And then finally, let's just import use effect and use state hooks from React so we can set some state variables for our app in which we can store the balance of the user, the recipient, etc., etc. So now in your app functional component, firstly, what we can do is we can destruct the address and is connected functionality from the use account hook from Wagmi, and we'll also destruct the connect function from use connect hook using our MetaMask connector we also brought in from Wagmi. So this connect function will allow us to connect to the desired chain we set up in our index.js file. All right, so with this set up, we have this connect function and we have the connect your wallet button. So let's add a onClick event over here. OnClick, scroll down over here. OnClick will be equal to the connect function. So we'll connect using MetaMask as you press the connect your wallet button. But then as we connect, the use account hook will get the currently connected wallet's address and a Boolean of whether a wallet is connected or not. So let's conditionally render on the page the button or the wallet that is connected to the page. So over here, if we have a is connected state, let's render something and otherwise something else. So go on the next line over here. Our button will be rendered only if there isn't a is connected state. So it will go after the colon over here. And then, sorry, it's a bit blurry, but we'll style this nicely very shortly. Now, if we are connected, let's just render the connected wallet address. So let me just paste in over here 2 headings like so. So now if we are connected, we will get the address that is connected and presented on the page. Now let's style this page nicely. Option Shift F like so. And now save this. Let's jump back into our web browser and see if it works. So jumping into Google Chrome over here. Seems like we have 2 connect your wallet buttons. Let's jump back into Visual Studio Code. Let's remove this that's outside the conditional, like so. Jump back in. So now we have only our connect your wallet button because we don't have a connected account over here. We're not connected. But now 0x42 is the account we should be connecting with. Let's connect your wallet. MetaMask pops up. How cool is that? Account 1 over here, which is 0x42. Let's press next and connect. And look at that, almost instantaneously, we got connected wallet is 0x42. And now if we go to jump into MetaMask and disconnect from this web page, go ahead and disconnect this account. Look at that, automatically our account is removed from this web browser. And we can do this for a different wallet. So let's connect our wallet. Let's change to account 2 over here, which is 0x5DA, like so. Press next, connect. And now we are connected with this account. How sweet is that? So everything is working now beautifully. Let's switch to account 2 over here and disconnect this one, disconnect this account. And now with this information, we can go ahead and make a call to our backend, which will get the current Chainlink balance for these wallets on the Polygon Mumbai testnet. So if we open up MetaMask over here, account 2 over here has 0.1 in Chainlink tokens on the Polygon Mumbai testnet, and account 1, if we jump over to account 1 over here, they have 0.6 Chainlink tokens on the Polygon Mumbai testnet. So let's just go ahead and check out how we get those balances using Moralis. So if we jump back into Visual Studio Code, we should notice that we have the backend folder. In here, we have a index.js file, which is already built for you. It is a very simple Express app, which has one endpoint called getBalance. And what we do is from the request to this endpoint, we get the address that is sent as a parameter and use that as a key for our Moralis EVM API call to the get wallet token balances. What else we pass is the chain ID for Polygon Mumbai testnet and the token addresses we are interested in. And this is the token address for the Chainlink token on the Polygon Mumbai testnet. So this will give us the balance for Chainlink tokens for the queried address. So the response we get from the Moralis EVM API, we get the first element in the array and get the balance and divide by the decimals. And if we have a balance, we send that back to the front end who requests it. And otherwise we send a balance of 0. And what you'll notice here as well is that before we start up the server, we go ahead and initialize Moralis by using our API key, which is stored in our .env file. If you don't have a Moralis API key, you can get one by going to your browser, searching moralis.io. You'll come to a page like this. You can create an account for free, or you can log in. After you've logged in, you'll arrive at the admin dashboard, where you can over here in the left sidebar, press Web3 APIs, and you have an API key generated for you, which you can just copy over, jump back into Visual Studio Code, and place it in the Moralis key variable in the .env file. Then this should be able to start off your server, and you can start making Moralis EVM calls through the get balance endpoint. So what we'll do is we'll launch this backend server up on port 3000. So what we'll have to do is open up our terminal. Let's go ahead and close our front end. For now, cd back one folder and cd into the backend folder. Let's just clear the clutter, and over here, install all the dependencies running npm i. And then you can go ahead and start off the server by running node index.js. And now we are listening to requests. So now running a API call to our localhost 3000 get balance endpoint, we should get as a response whatever address we sent as a parameter, their Chainlink token balance on the Polygon Mumbai testnet. So we can test this out by jumping back into our front end folder. So let's close down this index.js file. And here in the front end folder's app.js, let's import Axios so we can make a call like so. Let's close down the terminal just for now and this. And then we can go ahead and create a asynchronous function called getBalance, for example. And this getBalance function, what it does, it creates a Axios get request to our getBalance endpoint on localhost 3000, like so. And we store the response in this response variable. And now if we want to set the balance that was responded from our backend, we have to create a state variable here in our app. Let's call it, for example, user balance, like so. Set it initially to null. And as you notice, we set the address parameter to our get request to the address that is connected. This is why we'll get that user's balance. So we can just set the user balance over here, set user balance to whatever the response data is equal to. Now, we only want to make this get balance function call if we are connected. So let's go ahead and create a use effect over here, which is launched every time we connect to Web3 in our application. So over here, go ahead and run use effect and create an arrow function, which is triggered when is connected or the address changes. And we'll only want to run this if we are connected. So if we are not connected, we'll just return and not run the rest of this code chunk, but otherwise we'll run the get balance function and set the user's balance. Now, the last thing we can do is we can go ahead and in our is connected state, we can display the user's balance. So over here, now as we connect our wallet, it should create that backend request. And as soon as we get a user balance, we can display that balance over in that front end like so. So let's save this. And now we should be ready to go. We open up our terminal, create a new terminal window as we want our backend to still be running. Let's cd into the front end folder. And now as we run npm run start for our React app, it should start at a different port, for example, 3001. Let's press yes. Seems like we're getting some sort of error because anything isn't displaying on localhost 3001. Let's jump back into Visual Studio Code. And over here where we set our user balance, we're setting it to response.data. Let's set it to response.data.balance like so, because in our backend, if you check out the index.js file, we send as a response a object with the key balance. So now we should be able to get the actual user balance. Let's jump back over into Google Chrome and look at that. Now, as we are connected already with our account 1, we are connected, we get the Chainlink balance of 0.6 link. Let's disconnect this account and go ahead and connect our wallet. But this time, let's connect account 2, which should have a balance of 0.1. Let's press next, connect. And look at that, our Chainlink balance automatically updates to 0.1. How sweet is that? So now the final piece of the puzzle is creating 2 input fields, selecting a recipient for our Chainlink and amount that we want to send from this account that's connected, and then making a call to the Chainlink smart contract to send our Chainlink from our web app. So let's go ahead and implement that by jumping back into our app.js file. Here we can get started by creating the state variables that store the receiver and amount that we want to send. So here we create a send amount state variable and a receiver, which we initialize the 0 and an empty string. Then let's create 2 functions where we can change the state of these state variables, like so. So the function to change the send amount changes the send amount to whatever is changed in the input, and the same thing for the receiver. So now we can go ahead and create those inputs in our front end over here under our chain link balance. Let's create two inputs like so. Let's close this down a little bit so you see. So we have one input where the type is number, where we have the send amount, and another input where the type is text, where we can change the receiver address, wallet address. So if we save that, jump into Google Chrome, now you see it looks something like this. We can set the amount we want to change, we want to send, and the recipient. Final thing is now creating the functionality to actually send this amount and to this recipient. So what we'll do for that is we'll get some other functionality from Wagmi and import them over here like so. So use prepare contract write and use contract write. So use prepare contract write just prepares all the data that is needed for actually writing to the contract, and use contract write will actually implement the writing to the blockchain. So let's take a look at the Chainlink smart contract and see the details that we need to send. So jumping into Google Chrome and jumping into the Polygon Mumbai Testnet Explorer, like so. Here we are on the Polygon scan Mumbai, and we have the token tracker Chainlink, which is this address that we're also using when we're making our Moralis API call. If we check out the contract tab over here, we have all the smart contract details and the write contract. Here we see all the functions that we can write to on this Chainlink contract, and one of them is transfer. So this takes in two inputs, a true address and a value, just like we have in our front end over here. And then we can send that value to this to address using the smart contract and writing to the smart contract. One other thing you'll need is if you go to the code section over here, scroll all the way down, you'll have the contract ABI, which is the application binary interface, which will give us the information of the details that writing to this contract requires. So go ahead and copy that, jump into Visual Studio Code, and in the file directory, you'll actually see that in the front end source folder, we have this ABI already pasted in here, and we can find the transfer function. So go ahead and find for transfer. It should be over in here, the third one, which is a transfer function. It has two inputs, a to and a value, which are of type address and uint256, and it is of type function. So this is what we'll use when we're preparing our smart contract call. So jumping back into app.js file, one last thing before we can prepare our contract write, let's go ahead and create a debounced variable for our send amount and our receiver, because otherwise these variables will be re-rendered every time the page re-renders. So to avoid this, we use the use debounce hook that is already in the source directory, the use debounce hook over here. So just make sure to import it. All you have to know here is that it just stores the send amount and receiver and only updates it at a maximum rate of every half a second. So like so. So we'll use the debounce receiver and debounce send amount as our variables for our preparing the contract write. So now finally, let's prepare our contract write. And when destructuring it, it will give us a config variable. So for the contract write, we define the address we want to make the smart contract call to, which is the Chainlink token call on the Polygon Mumbai testnet, chain ID over here. For the ABI, we bring in the ABI from our ABI.json, like so. So the prepare contract write hook knows the application binary interface to use. And then as the function name, we call the transfer function, defining the two types of inputs it takes, a address and a uint256. And as the arguments, we pass this address, which is the debounce receiver, and the debounce send amount. And finally, this use prepare contract write will only be enabled to prepare a contract write if we have a send amount set. With all this set, this prepare contract write will always update at a half a second interval as we update our receiver and send amount. So then we can destruct a write function from the use contract write hook, just like so. So now we have this write function, which will write with these informations that we've set in the prepare contract write hook. And then all we have to do is write to the smart contract when we press a button. So scrolling all the way down, let's go ahead and create a button underneath our last input, like so, which is disabled if the write function isn't active, and on click, we just use the write function and the button says send. And a little nice to have is just in our use effect, let's go ahead and rather than just returning, let's go ahead and if we are not connected, let's set our state variables to the initial states like so. So we set our user balance to null, receiver to an empty string, and our send amount to 0. And then we chuck our return statement in this conditional as well, like so. So every time we disconnect, we nullify all the input fields. Save that, and now we should be ready to go, and you should be able, using the Wagmi Web3 library, make a contract write to the Chainlink smart contract on the Polygon Mumbai testnet with just these few lines of code. How sweet is that? So jumping back into Google Chrome, just open up our React app, and you see our send button is disabled at the moment. And that is because we don't have a valid recipient and our value is 0. So let's go ahead, and we have 0.1 link for this account. So let's change to the other account. Let's go to MetaMask, disconnect this account, and then go ahead and connect your wallet. Connect account 1 over here. Next, connect. And now we're connected with account 1, which has 0.6 link, which is better. Let's go ahead and get an address we want to send to. Let's go ahead and get account 2 over here. Copy that. We're on account 1 right now. We should have 0.6 link, which is right. And paste the address in here. And as the amount that we want to send, let's go ahead and send, for example, to link. And because link has 18 decimal points, let's add the decimal points 1, 2, 3, 4, 5, 6. Copy all of these and paste them 2 times. Reduce 1, so we get 0.2 link, and now we should be able to send 0.2 link to our account 2. Press the send button, MetaMask pops up, ask us, do we want to write to the smart contracts transfer function, send 0.2 link to our account 2. Let's go ahead and adjust the gas so it actually goes through. Let's go ahead and set high gas, save that, and now go ahead and confirm. Now if we check out MetaMask over here, the send link 0.2 has just gone through. Our assets say that we have 0.4 link. If we go ahead and connect our account 2 over here, let's go ahead and connect this account. See that we now have a Chainlink balance of 0.3 link on 0x5DAD. And now as we disconnect from this account, we go over here, disconnect to this account. So now we're only connected with 0x4D, which has a Chainlink balance of 0.4 link. Open at MetaMask, and that is exactly the case. Account 1 over here has 0.4 link. So that is how simple it is to write to a smart contract like the Chainlink token on the Polygon Mumbai testnet using a React app, Moralis, and the Wagmi Web3 library. I hope this video was very informative for you, and it'll help you start making smart contract interactions through your React apps. I'll catch you in the next one.